I would like to introduce your first presenter for today. She is the President and CEO of NARSAD, Ms. Benita Shobe. Ms. Shobe, you now have the floor.
Good afternoon. It's a wonderful pleasure to be able to welcome you to our webinar. We are in Nashville, the volunteer state, and we are specifically at Vanderbilt University. NARSAD, as many of you know, is now the Brain and Behavior Research Foundation, and we have awarded over $250 million that have helped fund discovery or research leading to recovery. Since 1990, NARSAD has funded $4.69 million of research at Vanderbilt University. 14 young investigators conducting ongoing research are currently at Vanderbilt University. It's our pleasure to have with you today Dr. Neil Woodward, who is a NARSAD young investigator. And Dr. Woodward is currently conducting research on processing speed deficits in patients with schizophrenia. Dr. Woodward is going to make a presentation, and after that we'll have a brief Q&A. As you have been instructed, you have opportunity as we are listening to Dr. Woodward to enter some questions as warranted. But I'd like now to just turn this over to Dr. Woodward.
Thank you, Benita. Before I get started, I'd just like to thank NARSAD not only for giving me the opportunity to speak to everyone today about some of the work that's going on in our lab, but to also thank NARSAD for supporting that work. It's a fantastic opportunity to be able to talk to people who are involved in this work and who are contributing to this work. So I'd like to thank everyone for tuning in and supporting NARSAD, and hopefully give you the opportunity to see some of the work that we're doing with the funding that we've received. So I'm going to be talking about the brain at work in schizophrenia today, and I'm going to be talking about some of the studies we've been doing using functional magnetic resonance imaging to look at cognitive impairment in schizophrenia. So we know that in schizophrenia there's pretty pervasive and severe deficits in cognitive functioning. So things like memory, for example, executive functioning, which entails problem-solving abilities, working memory, attention. These are all cognitive abilities that are impaired in schizophrenia. And I'm particularly going to be talking about what's called processing speed. And as you can see here on this first slide, that's probably the most impaired cognitive ability in schizophrenia. So let me just backtrack for a second, just give you an idea of what processing speed is. It's kind of a generic term that usually describes the ability to rapidly process information and perform relatively simple tasks. And one of the most commonly used measures of processing speed is called the digit symbol coding task. And it's a very simple task. I'll walk you through it right here. And so what people see on the sheet in front of them is boxes at the top that have a number in the top, and then underneath each number is a specific symbol. And each number is paired with a different symbol. And what we ask people to do is to go through and basically fill in the correct symbol in all these empty boxes as quickly as they can. It's a very straightforward, simple task, but patients with schizophrenia often perform well below normal on this task. And there's a lot of consequences associated with poor performance on this task. For example, better processing speed is associated with better social functioning, better self-care management, better vocational functioning. We know that individuals with schizophrenia who have more cognitive impairment have worse outcome in terms of their ability to obtain and keep employment, or go to school or go back to school if they have been in school. So it's really quite important, this deficit. So what we were really interested in is what is the cause of this processing speed impairment? What are the neural basis of this? Basically, what in the brain is going wrong that's contributing to this deficit? Then next we want to know is, can processing speed be improved? And if we can improve processing speed, will that lead to better outcomes? So if we're able to improve processing speed, can we then improve some of these outcome variables here, like social functioning and self-care management, for example? Now, there's some difficulties, though, in understanding or investigating what are the neural deficits that are contributing to processing speed. So the task that I just showed you, the digit symbol coding task, actually taps many processes. It involves visual motor tracking, for example. It involves something we call response selection, which I'll talk a little bit more about in a minute. It's a general attention task. It involves memory, it involves fine motor skills. Basically, it involves a lot of things. An analogy I like to think of is processing speed is like your car. If your car is running really well, it's going fast, everything's fine. But if it's not running as fast as it should be, it could be due to a lot of things. It could be problems with the fuel injector, for example. It could be a problem with the cylinder. The fact is you don't know exactly what it is until you take it to a mechanic, and a mechanic can then actually look at all these separate processes and try to figure out why your car's running. Why your car's running slow. It's the same thing with processing speed. So I'm going to talk about what's called response selection. And I think that this response selection is a key part of processing speed. If you think about what you need to do the digit symbol coding task, the first thing you need to do is be able to notice that this is a 2. So you need to be able to perceive and categorize that as a 2. It's pretty straightforward. Most people can do that without any problems whatsoever. Then you need to actually know that this specific symbol here goes with the number 2. And that process of choosing the correct response for a given stimulus is what we call response selection. And then the final step, you actually have to be able to execute the motor response. And again, that's pretty straightforward. We think it's really that stage where perception is converted to action is where I think and where my lab thinks patients with schizophrenia are having problems with. You don't think it's in perception and motor response per se. You think it's in this more complex process called response selection. So we want to investigate this process using functional magnetic resonance imaging. I'll just quickly go through what fMRI is. So many of you probably know that this involves people going into what's called a magnetic resonance scanner. And these are basically donut-shaped instruments where they lie down on a bed and they go into the scanner. And it's completely non-invasive. So we don't attach any electrodes to people. We don't inject them with anything. They literally just lie on the bed and the bed goes into the scanner. We do some things just to make sure that their head is stabilized. So there's a cushion that provides support and stuff like that. And we ask them to minimize their head movements while they're doing the task. So while they're in the scanner, they'll actually do a task. And we record basically blood flow to regions of the brain while they're doing the task. So this is what the images that we get from the fMRI scanner look like. This is one slice here of the brain. And you can see here that this little green box shows you the signal that we get, which is basically an indirect measure of blood flow over time. So by comparing blood flow during one task here, which is in green, compared to when they're doing another task, you can actually create these nice images of changes in blood flow, which reflects changes in brain function. So these regions in red here at the bottom would be regions of the brain that are more active when people are doing the second task here in blue compared to this green task here. So what is the specific task that we're going to have, or we have our subjects do? As I said before, it's a response selection task. And so basically people will see a cue here that says you're going to be seeing a colored circle. It could be one of two colored circles. It could be a green or purple one in this case. And then you just have to press the correct button when you see a specific circle, a colored circle. So in this case, if you see purple, you would press your left index finger. If you were to see green, you would press your right index finger. Now, under one condition of the task, it's a very simple low response selection load task. So there's only going to be one of two colored circles that could appear. In another condition, called the high response selection load condition, it could be one of four different colors. So in this case, they could see a red, a purple, a green, or a blue circle that might appear. So this one's a little bit harder now because they have to choose from one of four possible responses. So while people are in the scanner, we have them do the low load and high load conditions of the task. And then we compare those conditions. So first, let's just look at behavior. So this here is reaction time on the left, and underneath at the bottom here on the x-axis on the right here is a low load condition and the high load condition. And the control group here is shown in blue, and schizophrenia patients are shown in red. And you can see that reaction times under the low load condition are a little bit slower in patients, but they're not too much slower. However, when we go to the high load condition, you can see that our individuals with schizophrenia are much slower than control subjects. That is, the line here is much steeper. So as the task gets a little bit harder, the reaction times go up much more so in people who have schizophrenia than control subjects or healthy subjects. So we can see right away that we're getting at some of this slow processing speed deficit with this task. And in fact, when we look at the correlations between the response selection task and the digit symbol coding score, you see a pretty robust correlation. So let me just walk you through this slide. So this here, reaction time slowing, is the difference between the high and low load conditions of the response selection task. Basically, the higher your score here, the longer your reaction times are, the worse your performance was on the response selection task. And you can see that that correlates with digit symbol scores. So the slower people were on the task, the poorer they did on the digit symbol coding task. It suggests that this process of response selection is critical to perform a digit symbol coding task. So what's going on in the brain when people are doing this task? So this is our healthy subjects here, and the regions in red are the regions that are more active during the high response selection load condition compared to the low response selection load condition. And we see three brain areas that are prominently activated. They're called the intraparietal sulcus, which is in the parietal lobe, an area called the premotor cortex, which is in the frontal lobe and is involved in motor planning, and then a region here called the inferior frontal junction. So these are the three brain regions that are critical to response selection. Now, when we compare our control subjects to our patients with schizophrenia, we see some marked differences. So again, here on the top, I'm just showing you the healthy subjects again. And you can see that those three brain regions are activated. And this here is on the right-hand side, this image here, is what we call an axial slice. And this is basically just if we were able to look at the brain by taking literally a slice of the brain, so if we were able to look inside the brain here, if we were just cut the brain along this line, it would look like this in a cross-sectional view. And you can see the brain regions that are activated here in red. Now, when we look at our schizophrenia subjects, we see actually that there's more brain regions that are activated when they're doing this task, which is kind of surprising. We thought maybe there would be some regions they would show less activity in, but what's actually going on is that they seem to be recruiting more brain regions to do this task. And in particular, it's these regions here in yellow that I've circled. So this is an area called the dorsolateral prefrontal cortex. And you can see that patients activate this region, but control subjects don't. And you can see this here in this axial slice also, that these regions are being activated in patients, but not in healthy control subjects. So we were very interested when we saw this, and we kind of wanted to probe it a little further to see if this was related to task performance. And in fact, that's what we see. So this region here on the left is that dorsolateral prefrontal cortex region that I just showed you that's more active in patients. And it correlates with the reaction time scores from the response selection task. So basically, the poorer the response selection, the more active that region was, suggesting that maybe this is some compensatory mechanism. So they're actually recruiting more brain regions to perform this task, and that these regions are not normally part of the circuit that's involved in response selection. So this is kind of the work that we're doing, and we're kind of probing this further now. We actually want to see if there's, if we can run more subjects and actually see if there's additional regions that they might be activating in addition to these regions. So is it just these specific regions, or are there actually other regions that are also being more activated? We want to also look at the relationship between brain function and some other cognitive functions. So I've been talking about processing speed, but maybe this is something that is related to working memory and other tasks also. But critically, what we want to really do is now see if there are things that we can do, if there's perhaps cognitive remediation or cognitive training strategies that we can apply to individuals with schizophrenia to see if we can actually improve response selection. And I started a collaboration with a friend of mine, Paul Dutz. He published a paper a couple of years ago which was looking at healthy individuals and just seeing what happened in the brain if you train people on these types of tasks. And the very interesting thing was that people were able to get better over time as they trained, but that was also associated with changes in brain function too. So the next step that we want to take is to see if these similar types of interventions can be applied to patients with schizophrenia to alleviate some of these response selection deficits that we see. And also, we want to see if improving response selection generalizes to other areas of cognitive function also. So if we're able to improve response selection, can we also improve things like working memory or attention skills more broadly? That's actually the next direction that we're going to be going in. So one of the great things about NARSAD funding is that we were able to do something that is probably not something that we can typically apply for federal funding right away. They like to see a lot of pilot data before they give you a large federal grant. And quite often it's hard to get pilot data if you don't have funding. So it's great that NARSAD is able to step in and support these kind of projects. So as I said, the next steps that we're going to be taking are actually to see if we can improve response selection in schizophrenia, whether it's through training programs or actually possibly through pharmacological approaches. Are there potentially drugs out there that are associated with improving response selection that we can try? The next question then would also be, if we can improve these functions, if we can improve cognitive functions through either training or pharmacological approaches, does that then lead to improved long-term functional outcomes? So are we able, through improving cognition, are we able to then improve vocational ability? Are we able to allow people to get back to a place where they can go back to work, where they can seek out employment, or can they go back to school, for example? Does it improve social functioning? Does it improve things like self-care management? Basically, can we improve their cognitive functions, for example, so that they're able to remember to take their medications more often? Those are the types of things that we really hope to tie this work to eventually, because ultimately it's improving the lives of people that are affected by this illness that we're really interested in. And I know that I've gone a little fast, actually, as I look at my watch. So that's pretty much wraps up my part of the presentation. But it saves more time for questions. Before I end, I just want to make sure that I thank everyone that's been involved in this work. In particular, I want to thank Dr. Herbert Meltzer and Stefan Heckers, who have been my mentors for this work. Brittany is an RA in my lab. She's been running a lot of these subjects. She takes care of a lot of the day-to-day stuff. Austin and Kristen are also research assistants who help run some of our subjects too. Of course, again, I really can't thank NARSAD enough for providing funding to support this kind of work. We also got a little bit of funding from what's called the Luton Society too, and that was used to support some of this work also. And finally, I can't say enough about how appreciative we are to the patients who volunteer to be in our studies, and also healthy subjects too who participate in our studies. This type of work is it takes time, and so these people come in and they're here for 2 to 3 hours. An hour of that time is spent in a scanner, which these tasks are kind of boring, and often they're in the scanner, which isn't the most pleasant of places. It's a little bit uncomfortable, but without them, we wouldn't be able to do this kind of work. So we're just extremely grateful for them for participating in our studies. And I will wrap it up there and turn it over back to Benita for questions.
Thank you, Dr. Woodard. We have some questions that were sent in advance of today. So we want to get to some of those and also remind participants that are on the phone that you can type in a question in the Q&A section. But the first question really was, what role has NARSAD played in your schizophrenia research?
Yeah, so as I was mentioning before, it's, we come up with these ideas, and things that we want to look at in individuals with schizophrenia and healthy subjects, and it's really great to be able to go to a group like NARSAD and apply for funding. As I was saying, to get federal grants is very challenging, particularly for a young investigator like myself, where they like to see a long track record of research. They like to see a lot of pilot data that you've collected. So for people who are just starting out their research careers, where we don't have all of that pilot data and stuff like that, it's really great for us to be able to go to an organization like NARSAD. I'm sorry?
We have one question from someone who's on the phone. So let me read this to you and see if we can get this answer, because it relates directly to the presentation. Were patients on medication? How do you separate out the illness from the side effects of the medicine, which seem to cause cognitive problems?
That's a fantastic question. So there's two main classes of medications out there. There's the older antipsychotics that people have probably heard referred to as typical or first-generation antipsychotics, and they include drugs like haloperidol, chlorpromazine. Then there's another group of drugs that are called atypical or second-generation antipsychotics, and they include drugs like olanzapine, risperidone, quetiapine, clozapine, for example. And there's been quite a bit of debate about the effects of these drugs on cognitive function. So I can tell you that in our study, and individuals that we've been looking at, they've all been on atypical antipsychotics, so they've been on the newer drugs. It's pretty rare that we see subjects that are on the older ones. Now, the effects of these drugs on cognition, the take-home message is that the older drugs, the typical, did have some adverse effects on cognition. So they tended to make people a little bit slower. So, for example, they interfered with processing speed. They interfered with attention. And they also caused some motor side effects also. The newer drugs, the atypical, don't have these adverse effects the old drugs did. In fact, they might have a slight beneficial effect on cognitive function. Now, it's a debatable area, but at least it appears that they don't have any negative effects on cognitive function. So we're fairly confident in the work that I've shown here that the results aren't confounded by medication effects, because all of our subjects were on atypical antipsychotics.
Okay, thank you. This is another question that was sent in advance. What breakthroughs do you expect to see in schizophrenia research in the next 5 or 10 years? Are there new neuroimaging techniques or other new technologies on the horizon that will advance research?
Yeah, that's another great question, and I don't want to be speculating or prognosticating about what the next big breakthrough is, because honestly, breakthroughs, if we knew they were coming, they wouldn't necessarily be breakthroughs. So often they tend to be things that just come out of the blue. So with regards to imaging technologies, the area of neuroimaging is just really remarkable, because it allows us to look at the brain while it's actually doing things. Not only that, but we can look at the brain, the structure of the brain in exquisite detail. And I think that what we're going to see over the next 5 years with neuroimaging is maybe not so much new methods, but rather new ways of using the technology. So I don't think you're going to see a whole new branch of imaging, but what I think you're going to see is people discovering new ways to use MRI to look at brain structure and function. That's where I think the real advances are going to come from. And I also think it's going to be advances in the way we analyze the data also. So if you think about what a brain is doing, what I've shown you now looks very interesting, but it's still a relatively crude measure. We're looking at blood flow changes in the regions of the brain. What we really want to be able to know is how are these regions of the brain communicating with one another? Because that's how the brain works. It's not just one region that operates in isolation. It's regions that communicate and work together to perform a specific function. So I think that's where you're really going to see the advances is in the ways that we are able to analyze this data and basically piece together how these regions are talking to one another and how that process is altered or disturbed in psychiatric illnesses like schizophrenia.
There's a question from a participant. How many subjects are in the control and experimental group?
So far, the data that I showed you today, we have 13 control subjects and 16 patients that we've run through this experiment so far.
Is that optimal?
For an imaging study, they generally, we like to get around 20 groups 20 subjects per group, sorry. So we're pretty close to that now. We're actually scanning another patient tomorrow, and then we're hoping to recruit a few more here within the next month or so.
Okay. Here's another question that was sent in advance. Schizophrenia and mental illness in general carries a lot of stigma and is misunderstood in much of society. What role do you think research and the work that you do has in breaking down that stigma?
That's a great question. And I think the thing that we can do is, by showing that these illnesses are diseases of the brain and that the brain is like any other organ. It's like the heart, it's like the liver. It gets sick, it gets damaged. I think that can help alleviate a lot of the stigma that's associated with the disorder. I think if we're able to view this as not, we can't view mental illnesses as an intrinsic weakness of the person's mind or something like that, because we just know that that's not true. We know that there's regions of the brain that are altered in these disorders, and then that's contributing to the disease process. So I think that by really moving towards a biological basis of mental disorders, I think will help alleviate a lot of the stigma.
Meredith, I need your help on going back one. There's a question just before this one.
Sure. Okay.
Thank you. So dealing with a schizophrenia patient, it seems that too much is going on inside of his head. So does that means that he just can't process, or let me restate this one. I'm having trouble with this question. I'm sorry. In dealing with a schizophrenia patient, it seemed that too much was going on inside of his head. So that means that he just couldn't process, as opposed to taking on too many tasks at one time?
Yeah, that question actually makes a lot of sense. So one of the things that patients often talk about is that they're unable to filter out a lot of information that's coming at them. So if you or I are able to filter out things like street noise, for example, if we're walking, so we're still able to think about something else while we're walking on the street, and we're able to ignore things like street noise and whatever else is going on. Patients with schizophrenia often report they have a very difficult time shutting things out like that. And so that they're unable to really focus on thoughts because there's just so much getting in at any one time. So that's certainly one of the things that they talk about. Now, how that relates to the work that we're doing, that's a great question. I don't know how we would go about answering that, actually. What we can do, and what we have not done yet, would be to actually look at the relationship between some of the specific symptoms of the disorder and performance on these types of tasks. And that's something that we need to do once we are able to get more subjects. We would definitely like to do that.
Okay. And here's another question from a participant. When do you think that you might start working with schizophrenia patients to see if this type of research might improve their condition?
Yeah. So that's, like as I was saying during my slides, that's our goal, is to, once we've characterized the nature of the deficit, so once we're able to find out what brain regions are involved, then we're going to go to actually, that will help us actually decide what type of interventions might be most appropriate. So the work that I showed you on the last slide showed that a specific type of training improved function in a specific brain region. Now, it may be the case that a different type of training might be required to improve function in a different region of the brain, and that might be more relevant to schizophrenia. So what we hope to do, we actually just recently applied for a small federal grant, is actually to further understand the nature of this deficit in schizophrenia. So, for example, is it specific to visual stimuli and motor responses? So is it specific to visual motor response selection? What if we had people performing reaction time tasks that involved making vocal responses to auditory stimuli? Would we still see the same deficit? So does it relate to this core unitary response selection function, or is it specific to the type of modalities of the stimuli that we use and the type of response that people were required to make? For example, if it's specific to motor responses, then we might want to use a training paradigm that really focuses on improving motor responses. And that's kind of what we hope to do next. And we'll be in a very good position to say, okay, these are the types of cognitive remediation strategies that are best, that are most appropriate for the types of deficits we see in patients. So, timeline, I don't know exactly when, but I certainly hope that within the next 3 to 4 years we'll be actually working on a study where we're actually trying out some of these cognitive remediation strategies in patients.
This is a follow-up question, Dr. Woodward, from that same participant. Do you think that you'll ever use any kind of electric magnetic therapy in conjunction with your work?
I'm not. So the only type of therapy like that I think the question is getting at is what's called transcranial magnetic stimulation. And so that's basically a method where low-frequency electrical pulses are applied outside of the brain by an alternating magnetic current. So that induces changes in the function of neurons in the brain. And people have used this in depression, for example, and shown that if you apply this type of stimulation to a certain part of the brain, now this is not invasive. This isn't like deep brain stimulation. They literally just put a little magnet on the outside of your head and turn it on. And because it's alternating, it induces an electric current in the brain, and it subtly changes the function of neurons in that brain region. Now, this has been applied in depression. It has been shown to improve some of the symptoms of depression. I don't know much about its use in schizophrenia because I don't think in schizophrenia they know where they would use this, for example. We don't know exactly which area of the brain we might apply this type of therapy. So I'm afraid I can't answer that question maybe as thoroughly as the person asking it would like, but I do know that there is some work that's been done, not a lot out there, but I am aware of some of the, I have seen some of these studies.
Okay. I have another question that was sent in, advanced. Can someone develop schizophrenia after 40 years of age?
Yeah. So typically in schizophrenia, the typical age of onset is is in late adolescence, early adulthood. So usually around ages 18 to about 25 are where we see the peak of the onset. It is not uncommon, though, to see some people develop it at a later age. This is actually, interestingly, this is particularly true in women. In women, we see 2 peak ages of the onset. We see, as we do in men, we see the same onset between adolescence and early adulthood. But in women, we also see a later onset in around menopause, perimenopausal time. So late 40s, early 50s or so, you can see a second peak onset in women during that age range.
Okay. I think we're wrapping up with questions from our participants online, unless there's anyone else who would like to. We do have a closing question. I'm sorry. I'm being told I missed one. No, I did that. I'm sorry, here's another one. How long have you been working on the study?
So we got funding from NARSAD last February to do this study. So the data that I presented today has been literally acquired over the past year, almost to the, well, not to the day, but very close. So we've been working on this for about 1 year, this particular study.
This last question that we thought was a good wrap-up question, assuming that there are no more. And even if there are, please continue. We still have time. But How does research in schizophrenia relate to breakthroughs or potential breakthroughs in other areas of mental illness? You addressed a little bit earlier about the brain as a single organ.
Yeah.
So could you elaborate on that?
Sure. So schizophrenia is a very heterogeneous disorder. So it's not just that they have positive symptoms like hallucinations and delusions and paranoid symptoms, but they also have what's called negative symptoms. These are things that are very much like what we see in depression, for example. So there's a lot of cross-cutting of features of schizophrenia with other disorders. So things that we see in depression, for example, we sometimes also see in schizophrenia. So what we can learn about the negative symptoms in schizophrenia will hopefully also be relevant to some of the symptoms we see in depression. The same goes for bipolar disorder. It's not uncommon for people with bipolar disorder to have what are called psychotic features. And those psychotic features are very much like what we see in schizophrenia patients. So it suggests that some of these things that we see in schizophrenia, some of the symptoms, cut across a bunch of different disorders. So if we're able to learn about specific aspects of schizophrenia, that's going to inform other disorders too. So it might be the case that the causes of some of the psychotic symptoms in schizophrenia are similar, if not the same, as the causes of psychotic features in bipolar disorder. And some of the causes of depression in schizophrenia are very similar to what we see as the causal factors of depression in depression. So there's going to be a lot of things that we learn about schizophrenia that are going to apply to other disorders too.
Are there any closing remarks, Dr. Woodward, that you
I would just once again like to thank NARSAD for sponsoring the work that I've been doing, and also for inviting me to talk to everyone today. I think this is a great opportunity, and so often, we kind of work in our own little area, and we don't often get the opportunity to speak directly to people who are probably most impacted by the work that we're doing, unfortunately. So this is a great opportunity, I think, and I'm very appreciative to Meredith and Benita for putting this together, and NARSAD.
Well, we're certainly appreciative to you for the time that you take to prepare your presentation and to spend time with me and with Meredith. And last night with Dr. Meltzer, he did join us. So we really appreciate the time that you devoted to working with NARSAD. Your dedication and your passion and your intellect is certainly very admired by all of us, and we know that we'll be looking forward to the completion of this study and the final results, and know that it will impact the field appreciably. We also, of course, want to thank everyone for taking time to join us. This is the first time that NARSAD has had a webinar, and we hope to have others. We will also be seeking your feedback to let us know what we can do to improve both pre and post and during these webinars, improve the experience for you. And we will also have this recorded, so that it has been recorded, and it will be posted on the internet. So if you missed something, you can hear it again, and of course you can have the slides so that you'll have a chance to look through them again as well. So again, thank you all very much for all that you do. And thank you again, Dr. Woodard, and thank you, Meredith, who was leadership in putting this together. And we will talk with you again in the future.
Thank you.